All right, let's look at the nomenclature of anions. Okay, so first, just like we did with cations, we're going to break anions up into a couple of different groups. The first ones are simple anions. These are things where there's just one atom that carries a negative charge, like that. These will be very simple, as the name implies. That's why we call them that. We're going to look at polyatomic anions. These, again, as the name suggests, these are anions with more than one atom, right? Oxyanions, which are a specific subgroup of the polyatomic anions, and then we'll look at compound ions. Right? Being able to recognize what type of ion you have is important in naming it correctly. Okay, so the first ones, which are pretty easy, are the simple ions. And as I suggested on the last slide, simple ions simple anions are monatomic, right? Which means they've only got one atom, and if they're anions, they've got a negative charge. So again, these are things like chloride, oxide, bromide, and less common, phosphide. Okay. The way these work is if you have an ion or an anion that is just a single atom with a charge, you can tell what the charge is going to be by looking at the periodic table. This group over here, the noble gases, we'll talk about this later when we talk about electron configurations, but these numbers of electrons are very stable. So it's very stable to have 2 electrons. I like the purple, but it doesn't show up very well. Like helium, or 10 electrons like neon, or 18 electrons like argon, or 36 like krypton, and so on and so forth. Okay. Remember that these atomic numbers are the numbers of protons, and if you have a neutral atom, that's also the number of electrons. So because these numbers of electrons are very stable, the elements over here, the nonmetals, tend to acquire additional electrons in order to get the same number of electrons as one of the noble gases. So for example, fluoride, if we have a fluorine atom, the atomic number is 9, which means it has 9 protons and 9 electrons, but it can have the same number of electrons as neon if it gains 1 electron to become a negatively charged ion. And likewise, if we take sulfur, for example, right? Sulfur is atomic number 16, which means it has 16 protons. If it acquires 2 additional protons, then it'll have 18, which is the same number as argon. Okay. So sulfur tends to gain 2 electrons to form a -2 ion. For all of these ions, all of the nonmetals that form anions in this way, we can tell what the charge of the ion is going to be just by counting how many steps away it is from the noble gases. So fluorine has to gain 1 electron to have the same number of electrons as neon. Therefore, fluorine makes a -1 ion. Sulfur has to gain 2 electrons to have the same number as argon. Therefore, sulfur is going to gain 2 electrons and pick up a -2 charge. Nitrogen here, right, Nitrogen tends to form covalent compounds more often than ionic ones. But if it does form an anion, right? Nitrogen has 3 electrons fewer than does neon, and so nitrogen would tend to add 3 electrons to make an N3- ion. All right. So for all of these nonmetals, when they form a negatively charged ion, we can tell what the charge is going to be just by looking at the periodic table. Kind of like we did with the cations in group 1 and 2. Everything in group 1 loses 1 electron to become a +1 ion. Everything in group 2 loses 2 electrons to become a +2 ion. Same thing is true here, but in the other direction. Everything in this column is going to gain 1 electron to have the same number as noble gas. Everything over here is going to gain 2 electrons to have the same number as noble gas. All right, so that's the charge. And then for the name, for all of these, you just take the end of the element and substitute the suffix IDE. So that would be a fluoride ion, S2-. It's a sulfide ion. And if you had, for example, go in the other direction, bromide ion, then that IDE suffix would tell you that this is just a simple anion, just a monatomic anion, it's just a bromine with a negative charge. And then to figure out what the charge would be, whether it's going to be -1, -2, -3, you just look at the periodic table, and bromine is here. It has 35 electrons. Krypton's here with 36. That means bromine is typically going to gain 1 electron to have a -1 charge. So that would be the bromide ion. Okay. This is really important because we're going to look at different kinds of ions. We'll look at bromate and bromite and hypobromate and things like that, which are going to be different. So the key here is to recognize this suffix IDE. And when you see that IDE suffix, then you know that it's monatomic and that the charge is determined by how many steps away it is from the noble gas in the table. All right, polyatomic ions. There is a table of ions in the study guide that I gave you, and most of these really, the ones we just talked about, the simple anions like bromide and chloride and fluoride, those aren't on there because you can figure them out just by looking at the periodic table. The polyatomic ions in the table that I gave you are ones that you just have to memorize, and there's about maybe 10 in there. This is a list of a few of them. I'll just mention because some of these are really common. Hydroxide, super duper common, right? Acetate, very, very common. Chromate and dichromate. We actually do some work with these in the lab, but they're not super duper common. Permanganate's a pretty important ion. And look at take a look at the table that I gave you. I think azide is in there and a couple of other ones. Anyway, unlike the simple ions, there's no way that you can look at these formulas and then look at the periodic table and determine what the charges are. So for these polyatomic ions, the only way you can learn them, frankly, is just simply to memorize them. So I would encourage you to get some flashcards. I always say flashcards. Maybe I'm dating myself. You can make online flashcards nowadays. A lot of people like to do that because you can make a set of virtual flashcards, and then you can do them on your cell phone. People like to do that, and that's fine. But one way or another, I would recommend that you make flashcards out of all of these polyatomic anions and just work on committing them to memory, because it's going to be really important to know both the formulas and the charges for all of those anions. All right, and then we'll look at oxyanions. Oxyanions are also polyatomic, so they're essentially just kind of a subgroup of the polyatomic anions that we're just looking at. But these are ones that all have the same formula. There's some element here, a nonmetal like nitrogen, sulfur, phosphorus, something like that, and then some number of oxygens and a negative charge. And all of these end with the suffix -ate. So this is the sulfate ion, the nitrate ion, the phosphate ion, and so on and so forth. All right, and here they are. And again, just like the other polyatomic ions, unfortunately, there really is no systematic way that links this number down here, this subscript, with this charge, right? You can see that for nitrate, it's got 3 oxygens and a -1 charge. For carbonate, it's got 3 oxygens and a -2 charge, right? And for sulfate, it's got 4 oxygens and a -2 charge. So there's really no link between this subscript number and this charge. Unfortunately, the only way that you can learn these, again, is just to commit them to memory by using flashcards or something like that. And these are really, really important. First of all, because these are all extremely common, right? Really, really common as dirt, right? Common as fleas on a hound dog, right? I just made that up. I kind of like it. All right. The other reason is because we're going to look in a minute at variations of oxyanions. These all end in -ate, right? And you need to memorize the formulas for all of these ions that end with -ate, because we're going to look at how you can make similar ions that end with -ite or per-ate or things like that. And all of those names are fairly systematic and are based on all of these that end with -ate. So if you've got to memorize, what are these, about 7 or 8 of them? You definitely have to memorize this group. And again, flashcards is the way to go. All right. Now, for many of these oxyanions, there are related ions that are similar, just slightly different. The formulas are a little bit different, and the names are a little different. And one of the things that you can do is chlorate. I'm going to put an asterisk next to this one, because the -ate form is kind of the base we're going to work from. You can have similar ions with a different number of oxygens. And so chlorate has 3 oxygens, but there is a similar ion called perchlorate with 4 oxygens. And for all of these, chlorate, phosphate, sulfate, nitrate, bromate, all of these follow the same pattern. And that is, if you take the ion and you add 1 oxygen to it, in this case going from 3 to 4, the charge stays the same. Notice it's -1 here and it's -1 here. The charge doesn't change, but the number of oxygens does change, right? And when you add an extra oxygen, then you add the prefix per, right? So adding 1 oxygen changes it from the chlorate ion to the perchlorate ion. You can also change this one such that it has 1 fewer oxygen, -1 oxygen, and this will give you the chlorite ion. So notice again, the charge doesn't change, but the number of oxygens is decreased by 1. Right? So when you go from this ion here, remove 1 oxygen, the name changes from 8 to ite. And you can also remove a second oxygen to get ClO, minus 1 oxygen. I'm writing minus 1 oxygen. That's what I was supposed to write there. It's kind of scribbly. And when you do that, when you remove that next oxygen, then you add the prefix hypo to that. And hypo is a prefix that means under, like a hypodermic needle goes under your skin, right? So hypo means under or less than. That's a way to remember that this has fewer oxygens. Okay. All right, so for all of those oxyanions that we looked at on the last page, the number of oxygens and the charges are different for all of them, but this pattern stays the same. So for example, if NO3 is nitrate, right, we can remove 1 oxygen to make NO2. Again, this charge stays the same, and this would be called nitrite. Right. We can do the same thing for sulfate. Right. Sulfate ion is SO4, so that means that sulfite has 1 fewer electron, or 1 fewer oxygen, excuse me. So that would be SO3, right? Let's just do 1 more of these. So if bromate is BrO3 minus, right, then hypobromite, right, the hypo and the ite means that we've gone down 2 steps, we've lost 2 oxygens. Hypobromite then would be BrO minus. And perbromate we got the 8 suffix and the per in front of it. That means we've gone up 1 step, we've added 1 oxygen. So perbromate would be BrO4 minus. Okay. All right, this pattern is important. We're going to look at, when we get to naming acids are going to have a table very similar to this for naming the acids of all of these different oxyanions. So this is really important. Okay. All right, now we can also make compound ions, and compound ions kind of look like this. If you have an anion which has a charge of -2 or -3, then you can add a hydrogen to that, and hydrogen ions, because they're in group 1, hydrogen ion has a +1 charge. So if we add a hydrogen to a sulfate, we get a new formula that looks like that. And we combine these charges. The sulfate was a -2, the hydrogen is a +1, so the charge on this new ion here is going to be -1, right? It's just the sum of those two. And this ion here is called a hydrogen. Oh, I've actually already got it written there, don't I? A hydrogen sulfate ion. Now you can add one hydrogen to sulfate to make a hydrogen sulfate ion. Actually, I'll come back to that. Okay, so if you add a hydrogen, then the formula changes by adding one hydrogen, and the net charge goes up by 1, okay? Because the hydrogen has a +1 charge. So if we've got something like phosphate, right? Phosphate is -3. If we add a hydrogen to that, hydrogen is +1, so our new formula becomes HPO4, and our new charge is the -3 and the +1, which is 2-. And so this would be a hydrogen phosphate ion. Now from the hydrogen phosphate ion, we could add another hydrogen. And now we've got 2 hydrogens in here. And our charge is going to be 2- from the hydrogen phosphate and +1 from the hydrogen, the net of -1. And so now I've got a phosphate that's had 2 hydrogens added to it, and this would be called a dihydrogen phosphate ion, and the charge is -1. Okay. Now this is the point I was about to make with the sulfate. You can add to the sulfate, you can add 1 hydrogen to go from sulfate to hydrogen sulfate, but you can't add 2 hydrogens like you can with phosphate, because if you add another hydrogen to this, you get this formula. This is a fine compound, right? That's sulfuric acid. But when you combine them, you got a -1 here and a +1 here, and so the charge is 0. Right? And if the charge is 0, then it's no longer an anion. And this scheme that we're using for naming these is only for anions. Right? So if this is neutral, this is not an anion anymore. In fact, we'll see later that it's an acid, and there's a different set of nomenclature rules for acids. Okay, so we wouldn't call this dihydrogen sulfate since it's no longer an anion. Same thing with the phosphate. We can add 1 hydrogen to make hydrogen phosphate, which is 2-. We can add 2 hydrogens to make dihydrogen phosphate, which is 1-. But if we add 3 hydrogens, we get H3PO4, and the charge now is 0, right? So this is not an anion, so this would not be considered a compound anion, and it doesn't follow those rules anymore. Okay, it only works if you add a hydrogen to get something that still has a negative charge. All right. All right, let's practice a couple of these. I think I've got 2 pages of these. So the first ones, I've got formulas, and you need to provide a name. So if you want, go ahead and hit the pause and see if you can work out names for all of these, and then unpause, and we'll look at them together. And I'll tell you how I got the names for them. All right, this first one This is a monatomic ion, right? It's just a sulfur. There's no oxygens. That means this is a simple anion. And if it's a simple anion, then you can just look at the periodic table. And if you look at the periodic table, you'll see that sulfur has 16 electrons. That's 2 fewer than argon, right? So sulfur is going to add 2 electrons to become, to acquire a -2 charge, right? And that's exactly what we've got here. So for that simple anion, all we do is change the end of the element to IDE and call that a sulfide ion. Okay. All right. Next one is NO3. NO3 minus. This simply is one of the ones that we memorized. This is one of the important oxyanions. And this one is the nitrate ion. BrO2 is not one of the ones that we memorized, but we did memorize BrO3, which is bromate, right? And since BrO2 has 1 fewer oxygens, you just go down 1 step in that table. And when you go down 1 step in the table, you change the 8 to ite. So that means this is a bromite ion. And then OH minus, this is one of the extremely common polyatomic ions. This is a hydroxide ion. You might not have them memorized yet because we're just going through this for the first time. But please do make the flashcards if you haven't already. All right. Cn minus. This is another one of those polyatomic anions. It's the cyanide ion. Okay. HCO3. Okay. That's not one of the ones that we memorized, right? But we did learn that CO3 2 minus is the carbonate ion, right? And if you look here, we've got an H on there. So if we were to add hydrogen to that and put an H at the beginning of the formula, and the charge, H plus, the charge would increase by 1, so it'd go from -2 to -1. So if we were to form a compound ion here by adding hydrogen, we'd get a hydrogen carbonate ion with a charge of -1, and that's exactly what we've got here. Right. So this one is hydrogen carbonate ion. Okay, next one, IO4 minus. That's not one that we memorized, but we did memorize IO3, which is the iodate ion. And so this one has 1 extra oxygen. So if we go up 1 step in that table by adding 1 oxygen, then we add the prefix per to the name of the ion. And so this would be, erase this to make room. Since we're going up 1 step in the table, we keep the 8 suffix, but we add the per prefix. So this becomes per iodate ion. Right. And then the last one, got a fluorine with a negative charge, right? You can look at the periodic table and see that fluorine, when it is a simple anion, it has 1 fewer electrons than neon, so Fluorine typically would gain 1 electron to get a negative charge. So this is just a simple anion, and we name it just like the first one up there, just by changing the end of the element name to IDE, and we'll call that a fluoride ion. All right, take a look at these. Again, go ahead and hit the pause button. See if you can write formulas for these, and then unpause it, and we'll look at them together. Okay, the first one, acetate ion, that's just one of the polyatomic ions that we've memorized. And again, you might not have it memorized yet, but I hope that you will very soon. That's C2H3O2 minus. That's important. Right? Hypobromite. Right? Remember that bromate is BrO3 minus. The prefix hypo and the suffix ite tell us that we've gone downward 2 steps in that table. So we've lost 2 oxygens. The charge stays the same, but the number of oxygens is decreased by 2. So hypobromite would be BrO minus. Carbonate ion. That's all of the ones that end with 8 are ones that we have memorized or should memorize. Carbonate is just CO3 2 minus. Okay. Bromide, if we see that suffix IDE, then we know it's a simple ion. There are no oxygens, so it's just Br. And in order to determine what the charge is, we look at the periodic table, and we see that bromine is 1 space away from krypton. So bromine can get the same number of electrons as krypton by adding 1 electron and taking on a negative charge. So bromide is -1. Now nitrite, we didn't memorize nitrite, but we did remember nitrate. And this suffix here, ITE, tells us that in that oxyanion table, the ITE suffix means we've gone down by 1 oxygen. So if we've removed 1 oxygen from this, it would go from NO3 to NO2, and again the charge stays the same. So that's nitrite. Okay. Hydrogen phosphate ion. Okay. This is a compound ion. We've added 1 hydrogen to it. So we can just look at phosphate. This is our phosphate ion. A hydrogen has a +1 charge. So if we combine those to make this compound ion, the charge is going to be the product of these two, right? Or not the product, the sum, excuse me. So we've got -3 and +1. And so we combine them, the net charge will be 2 minus. All right, then we've got selenide. It's not one you see terribly often, right? But the fact that it ends in IDE means that it's just a simple anion, right? Monatomic. Selen means that it's based on the selenium. So that's Se. And if you look at the periodic table, you'll see that selenium is directly beneath sulfur. It is 2 steps away from krypton. So when selenium forms a simple anion, it's going to add 2 electrons to make an Se2 minus anion. So that's the charge for selenide. And then we're just left with chromate. Chromate is just one of the ones on that list of polyatomic ions to memorize, and chromate is CrO4 2 minus. Wonderful. All right. make sure you practice those. Well, let me go on to the next page. So we'll just wrap this up. In looking at anions, first thing we looked at were simple anions. That's the monatomic, no oxygens, right? And you can figure out what the charge is just by looking at the periodic table. Then we looked at polyatomic ions. There are a bunch of them that don't have any pattern to them, and unfortunately you just have to memorize them. And among that group of polyatomic anions, there are a bunch of oxyanions, which have formulas that look like this. You know, this includes nitrate, sulfate, and phosphate, and so on and so forth. And it's important that you memorize all of those. Well, it's really important to memorize all of them, but particularly the ones that end in ATE, because the ones that end in ATE are the ones that we use in order to figure out the formulas for the ite and the hypoite and the per-ate and so on and so forth. So make sure you commit to memory all of those oxyanions, the formulas and the charges. And then we also looked at compound ions that you can form if you add a hydrogen to them. All right, now the next thing we're going to look at is the nomenclature of ionic compounds. And what you'll see when we get to that one is that the ionic compounds are named just by naming the cation and then naming the anion. So that part's going to be fairly simple, but in order to do that, you have to be really good at naming the cations and naming the anions. So please put some work into these and make yourself some flashcards and work on committing these anions to memory. All right, we'll move ahead and start looking at ionic compounds next.